Hello everyone. Today in this video we are going to discuss remainder theorem. In the remainder theorem, statement is telling that let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number. If p of x is divided by x minus a, then the remainder is p of a. What is the meaning here now? One polynomial is there, degree is greater than or equal to 1, and this polynomial is divided by linear polynomial. X minus a means linear polynomial, okay? P of x is divided by x minus a. Here the x minus a is linear polynomial and the p of x is the polynomial. Degree should be greater than or equal to 1, okay? But the divisor should be always linear polynomial. Then the remainder will be p of a. Okay, so before starting this one, let me remind you one thing now. If any polynomial is divided by linear polynomial, you must know remainder will be all the time constant. Okay, constant means what is the meaning? Degree should be 0. Remainder, the degree of the remainder should be 0. And also you know that any polynomial divided by another polynomial, remainder should be always less than the divisor. Here in terms of polynomial, the degree of the remainder should be less than the degree of the divisor. Okay, but here divisor is degree 1, that means remainder will be degree 0. Degree 0 is called constant polynomial. That one you must keep in mind. Okay, let us start now. Let p of x, if p of x is divided by x minus a, then by division algorithm we can write like this now. P of x is equal to x minus a into quotient plus remainder by division algorithm. Okay, if any polynomial is divided by another polynomial, remainder will be there, constant will be there. So that is nothing but dividend is equal to divisor into quotient plus remainder. But since the degree of x minus a is 1, therefore degree of Rx means remainder is 0. So degree 0 means what is the meaning? That is Rx will be constant. I will consider now R, okay? Remainder will be constant. The polynomial of degree 0 is called constant, okay? So it is true for every values of x. What is the meaning here now? I said when the polynomial is divided by linear polynomial, remainder will be constant. This condition will be true for every values of the variable. So now I took x value is equal to a. Okay, x value a I have taken now and I apply in the equation number 1. Okay, what is the equation number 1? P of x, instead of x you should write a, then x minus a minus a into q of x, q of a plus rx. Rx value is r now because remainder should be constant. A minus a is 0 now into q of a plus r. 0 and any number multiply means 0 plus r. Therefore 0 plus r is equal to r now. R is nothing but remainder, okay? Now this remainder is constant. This value will be constant now. So this constant value is denoted by p of a. Meaning is remainder will be p of a. Like this we can prove, okay? So here you must know one simple thing now. When the polynomial is divided by x minus a, remainder is equal to p of a. Yes or no? According to this, how a coming here? This divisor, 0 of this divisor. Already we have learned the 0 now. X minus a means what will be the 0 of this variable? Plus a. Here minus a given means plus a. Here plus a given means what will be the remainder? Remainder will be p of minus a. X plus 2 given means remainder will be p of minus 2. Here x minus 3 given means remainder will be p of 3. You must know how to take. Okay, when the polynomial is given divided by x minus 3, then if you want to apply the remainder theorem, you must know what is the 0 of this divisor. Okay, 0 of this divisor will be 3, so that 3 you have to apply in the remainder theorem. Okay, so this is the remainder theorem. It is useful to find the remainder when the polynomial is divided by linear polynomial. Okay, this can be applied only when the divisor is linear polynomial, otherwise we can't apply. And also this can be applied only to find the remainder. We can't find the quotient here. Only to find the remainder we can apply this remainder theorem. Factor theorem. The factor theorem is telling that it is a simple meaning when a number, or you have learned in the lower class, okay, factor, multiples we have learned. Actually factor concept we must know here. What is meaning factor? If the number is exactly divisible by another number, suppose for example 6 is divisible by 3, 6 is divided by 3, now we'll get 3 2s are 6, remainder is 0. When the remainder is 0, this divisor is called factor of the 6. Now you will say 3 is the factor of 6. Am I right? Okay, 3 is the factor of 6 now. Why? Since remainder is equal to 0. Okay, then in the converse meaning of this one, we can say that remainder will be 0 when if 3 is the factor of 6. Just opposite meaning now. 3 is the factor of 6 when the remainder is 0. Remainder will be 0 when 3 is the factor of 6. These two concepts we are going to learn here now. Just correct only now. Remainder 0 means 3 is the factor. If 3 is the factor, remainder will be 0. So these two concepts we are going to learn here now. One polynomial is there now. Degree should be greater than or equal to 1 and a be the real number. Then x minus a is the factor of p of x. X minus a is the factor of p of x. This is divisor now. This is the polynomial. This divisor will be factor of p of x when the remainder, this is called remainder. P of a is equal to, we have learned the remainder theorem now. When the remainder is 0, x minus a is the factor. Another thing is remainder will be 0 when x minus a is the factor of p of x. Let us start now. Okay, proof. We know already p of x is the polynomial. Now let p of x be any polynomial of degree greater than or equal to 1, and it is divided by x minus a. Then what will happen? When the polynomial is divided by any polynomial, by division algorithm we can write p of x is equal to x minus a into quotient plus remainder. Like this we can write now. When the polynomial is divided by any polynomial, quotient will be there, remainder will be there. So by using division algorithm, dividend is equal to divisor into quotient plus remainder. This is the dividend, this is the divisor. Okay, q and the r is the quotient and the remainder now. Then we'll apply condition now. If first one, okay, first condition, if p of a is equal to 0. What is the meaning p of a? Remainder. See, when polynomial is divided by x minus a, remainder will be p of a. When the polynomial is divided by x plus a, remainder will be p of minus a. Okay, remainder will be represented like this. Okay, so now the polynomial is divided by x minus a, remainder is equal to 0 now. When remainder is equal to 0, then what will happen? This apply in this condition, remainder is 0 now, so we can write therefore p of x is equal to, when the remainder is 0, this part will be 0 now. Polynomial can be written as x minus a into q of x. Okay, so when the remainder is 0, we can write like this. What is the meaning now? This polynomial is obtained by multiplying these two numbers. So 6 is obtained by 2 into 3. So 2 is the factor, 3 is the factor. Like that, p of x is equal to this one now. So this will be factor, this will be factor now. So we can say that, therefore, x minus a is a factor of p of x. You understood? Remainder is 0 now. P of a is equal to 0. Remainder 0. So x minus a is the factor of p of x. First part is over now. Next one, what we are going to prove is when x minus a is the factor of p of x, we have to prove remainder will be 0. Second condition, if x minus a is a factor of p of x, then okay, if x minus a is the factor of p of x, what is the meaning here now? X minus a is one of the factor of p of x. That means we can say then p of x can be written as x minus a into any one of the, meaning is x minus a is the factor now. That means this polynomial can be written as x minus a into any other polynomial. Okay, these two polynomial multiply means this one should come. Okay, so now when p of x is divided by x minus a, see this p of x divided by x minus a, what will be the remainder? Let us find out here now. Okay, so now p of x divided by x minus a, we have learned in the remainder theorem, p of x divided by x minus a means what will be the remainder? P of a will be the remainder. Okay, wherever x there, apply a now. A minus a into q into a minus a 0 into q into a, q of a. Any number multiply with 0 means 0 will come now. What we got? P of a is nothing but remainder. Polynomial is divided by x minus a, remainder is 0 now. When? Remainder will be 0 when x minus a is the factor of p of x. Meaning is this x minus a is the factor now. I divided, p of x is divided by x minus a, we got remainder is 0 now. Hence proof. Like that we can prove. Okay. So like this factor theorem we can prove. When remainder is equal to 0, remainder you must know p of a means remainder. Okay. When the polynomial is divided by x minus a, remainder will be p of a. If the remainder is equal to 0, divisor will be factor. Another condition is when the divisor is the factor of the polynomial, remainder will be 0. We have proved now. Remainder 0, x minus a is the factor. X minus a is the factor, remainder is equal to 0. So like this we can prove the factor theorem.